Hello everybody, Nick the Tiro. It's time to start talking about arrays. We have been using the declaration of variables, if we were counting the number of students or a particular student, but what happens when you have a collection or a series of things that are fundamentally the same? For example, cars. You might have a BMW, you might have a Mercedes or whatever, high price cars. How would we store that? Would we want to create a individual variable for every single car? That would get almost tedious. Say car one is equal to Chevy, car two is equal to Ford, car three, and you can see that gets very, very tedious. Programming languages allow something called an array. An array is a special type of variable that allows you to store a series or a list of data types. So let's say I created an array called cars. I can reference the individual elements in that list of cars. And we, in previous classes, we talked about indices, and that's going to become critical in our discussion. So it's going to be one type of variable called an array, and in Python we call that a list. Arrays and lists are not exactly the same thing, but we can simulate an array using a list inside Python. But we would then reference the individual elements within that list or array using an indice. Now, let me go up to my screen and we are going to do one of those DMOJ projects again. So this is going to be a two-part video. One is just to kind of work out the kinks associated with dealing with lists. And then the second video will be actually solving the problem that they want. So let's head up to my screen. All right, let's break down a program using arrays. You look at my screen here. I have this, again, from the DMOJ from Canada. Let's kind of read this. It says, the student council is looking to organize a school brunch where the proceeds will be put towards a year-end trip for the graduating class. The council members decide that the price depends on how many years you have been at the school. For someone who has been there for 1 year, the price will be $12, 2 years, 10, 3 years, 7, and 4 years is 5. So a decreasing scale. Immediately, that rings out, that would be a great array, an array of brunch prices. Now, let me flip to a little spreadsheet that I built. And in the spreadsheet down here, we're going to have brunch prices. It's going to be an integer array because they said it was $12 for the first year, 10, 7, 5. Notice that it's going to be an integer array. We're going to call it brunch prices. And I even put down the indices. So the first year is going to be at indice 0, second year, indice 1. Remember, I'm going to keep saying this over and over again. And, eventually it's going to stick for all of us. I still make the mistake all the time. We start counting at 0. So this is basically going to be a fixed array that, 4 elements in this array, with the first one being the price for the freshmen or first years, and et cetera, et cetera, et cetera. All right, let's go back. They say out of all the proceeds, 50% can be saved towards the end of school trip. What they're saying is they're going to create a brunch, and at the end, they're going to count up all the money, and half the money is going to go and pay for the brunch, and the other half is going to go and pay for the trip or contribute towards the trip. Now, let's take a look at input specifications. The input contains up to 10 trips, okay? And there's going to be 3 lines per trip. So we're going to basically iterate through 10 times. In this video, we're only going to do it one time. In the second video, we're going to do the entire project. I just want to get through the arrays, kind of do the heavy lifting here. And it says each of the trip. Okay, so they read for each of the trips, the first line will show the cost of the trip between $50,000 and $50,000. Boy, that's pretty expensive and pretty cheap. And then the next line is going to contain 4 floating point numbers. So the first line is going to be some kind of integer. I'm talking the input. The second line is going to be 4 floating point numbers, and that's going to be basically a percentage of the number of students representing the course. I mean the class. So let's say hypothetically there's 100 students, and the first percentage would be 25. So 25% of those 100 students will be freshmen. Let's say the second number is 0.2. Then we say 20% of 100 would be 20 students are sophomores, et cetera, et cetera, et cetera. It'll make more sense, be clearer as we go forward. And then the third line contains a single number, which contains the total number of students attending the brunch. All right. Don't worry about the special note. That will be covered in the second video. The second video will be somewhat optional. And basically, what they're looking for is an output of yes or no. If the student council needs to find other funding, so if the output is saying, if they take the brunch, all the money they collected in the brunch, and it's still less than the cost of the trip, then we're going to say yes. If the amount that they collected during the brunch is more than the cost of the trip, they're done fundraising. Now, let me go back to my spreadsheet here, and let's see. Let me say they have a percentage of students up here. All right, 1, 2, 3, 4 is that percentage of students. So we're going to create an array, but this time that array is going to be double. And you will notice, I'll just call the array percentage of students, 0.5, 0.2, 0.1, 0.2. Notice again, the indices line up. So the first year students who are at indice 0, they're going to make 50% of the brunch. People who are going to be participating in the brunch. The sophomores or the second year students, they're going to be 20% of the total number of students at the brunch. Try and do this all in my head. The juniors are 10% of all the students at the brunch. And then we have the seniors or the fourth years who are 20% of all the people at the brunch. Now, if we look at a distribution, let's say we get a total number of students, right? Well, I can then create another array. This array here, I'm going to create based upon the percentage of students. So we have the total number of students, and we can basically say 400 times 0.5, there'd be 200 freshmen, 80 sophomore, 40 juniors, and 80 fourth years. Again, notice that this is important. The indices are going to line up for us. So when we plan our arrays, we know that arrays are fixed. Whatever we initially create that array at, it's going to be fixed on that side. We can use that structure to help us. So basically, we're going to be creating a whole bunch of for loops, of definite loops. We know we only have to iterate through them 4 times. So why not go line up these arrays appropriately? So before we start coding, let me expand upon this. I kind of built this little flow chart here. It says, okay, we're going to input the cost of the trip, say, $4,000 for the cost of the trip. We're going to get also the number of students, and we'll break down I'll show you the data in a second. Brunch prices, percentage of students, distributed students, all these indices line up. And that is critical to make this as efficient as possible. And then down here, I just basically, did some hand calculation. It says $12 times 200 would be 2,400, but only half of that goes to the trip. So $1,200. Brunch price of $10 times 80 students would be 800 divided by 2, 400. Brunch price of $7 times 40 students is 280 divided by 2. And then for seniors, brunch price of 5 times 80 students would be 400 divided by 2. If we add that all up, we get 19,400. So what we'll eventually get for this program is the cost of the trip is $400 or $4,000. I'm sorry, the cost of the trip is $4,000. They've only collected $1,940. So what we should see is basically they need to go out and keep collecting money. So if here's the data here. So basically it costs $4,000. There's the distribution of students. There's the total number of students of 400. And the output should be yes, meaning that if the student council still needs to find other fundings, yes. Now let's go on to Replit and let's build this code. All right, I'm here with my Replit screen, and I'm just going to start with just kind of a base framework to work from, so I don't have to sit there copy. The other thing I'm going to do, as most of you are probably going to be quite familiar with, is I am not going to manually type this stuff in. I'm going to do a lot of cutting and pasting, so you guys don't have to see me do all my typos and things like that. So let's start this. First thing I want to do is I want to create an array with the brunch prices. We know they're integers. We saw it on the problem statement. So let me cut and paste my brunch prices. So it says this is going to be an integer array. There's my square brackets. We're going to call this array brunch prices. Notice that I'm beginning to use plural in here because I'm going to reference individual things, but basically the array is a collection of things. So oftentimes in programming, you're going to see programmers using the plural when they're talking about prices or when they're talking about arrays. All right, the next thing we need to do, let's go back to the problem statement. And let's just look at the sample input. It says the first line is going to be the cost of the trip. So let's put that out there. We're going to do a scan on that. We're going to get it from the keyboard. And we're going to say cost, my fingers are off, int cost of trip. And that's going to be equal to scanner, next, int. Again, I'll do a lot more copying and pasting in a bit. So that's going to get that first line of code. The next stuff when you're going to get the second line of code, if we go back to it, is going to be those 4 doubles. Those are going to be the percentages of students going to the given brunch. That is screaming an array. But before we do that, let's build that array. We're going to say double. There's our square bracket saying it's going to be array. We're going to call this percentage students. And this one, right now, we're just going to say double. We're going to instantiate with the double. And it's going to be 4. Right, so 4 elements or 4 parts of that array. Now remember from previous videos talking in class, once we establish the size of the array, it is fixed. Later on, if we need to shrink that array or grow that array, it becomes a challenge. What we would have to do is create a new array and copy stuff over that. So we want, in our planning phase, we want to know how many elements are there. Sometimes if you say, I know it's going to be under 100, then you set it to 100, right? So it doesn't always have to be exactly, you might want to potentially plan for growth, but understand once you set that array, it is pretty much in there. Well, that array is basically empty. I want to take that line and feed that line into the array. So, wow, that sounds like a definite loop there. We can determine it's going to be 4 iterations to read that line. Since it's fairly easy to determine the number of iterations, we're going to use an indefinite loop. We're going to do 4. So we're going to say 4 and integer I, and we're going to start it at 0 because indices and we count at 0. And we're going to say as long as I is less than 4, I know I keep saying this over and over again. 0, 1, 2, 3. So it's less than 4. It'll never get to 4, so it's going to be 0, 1, 2, 3. And then we're going to increment I. Get into the habit of thinking about what you're typing, and especially with these indices. I know it's very confusing to always start at 0, but that's just how it is. And then I'm going to say what I'm going to do. I'm basically going to do percentage students. That's this array up here. Going to say I, and we're going to grab from the screen. Let me close off my braces here. Actually, tab that over. Oh. Somebody would have said, Nick, you're making a mistake there. And I would have caught it eventually. All right. So let's read this out here. It says, for the integer I, as long as it's less than 4, iterate through. Basically, grab a double off the line, put it into the percentage indices, and then keep doing that. We'll do that 4 times. 0, 1, 2, 3, and put it in there 4 times. All right, let's pick up the pace a little bit here. So what did we do? We basically grabbed the cost of the trip. We grabbed the percentage of students going to the brunch. We put that into an array. Let's grab the total number of students now. Do the magic of cut and paste. All right. So we've pretty much covered our input, the data in which we're getting from. Now, let's build an array based upon the distribution of students. So if I have 100 students, I have 400 students, whatever number of students, we're going to build an array of that distribution. And that array is going to be based upon the total number of students times that percentage of students that's inside the array. That's screaming another definite loop. So let's do our for loop again. Through the magic of cut and paste, so I don't have to make typos. Make sure things line up. All right, so we're going to say for integer I equal less than percentage students dot length. This is hard coding up here. You should learn not to hard code. I chose to go hard code just for demonstration purposes. I knew the array was going to be 4. I programmed it to be 4, and I obviously put 4 here. But down the road, as you're practicing your programming skills, whatever programming language you choose to use, you don't want to hard code. So I'm going to use percentage of students, just like here, the length of it. Now, this length, you'll remember from previous videos and class discussions, is not a method. It is part of a variable of that array. So I can go and ask that array, what's your length, right? So instead of hard coding it with a 4, I've just basically said, base this on the, base this on the length of the given array. All right, so what is this going to build? This is going to build an array of distributed students based upon the total number of students times, so number of students times the percentage within that array, right? Well, we need to build another array here. What's the other array? How about the money that they collected through this brunch? So what do we have here? We now have a distribution of students. We now have the brunch cost. We made that. Now we want to see how much money they collected on a given brunch. Through the magic of cut and paste, make sure things line up. Now, in this regard, I misspoke here. We're not going to create another array. We're just going to use the ones that we have because we're now collecting money. We're collecting money, proceeds, whatever. So we really don't have to put those monies inside an array. We're just going to do one iteration through and do the total. So my total is going to be a double. We have the potential for decimal points here. And again, for integer I through the length of distributed students. So I'm finding the length. I'm not hard coding. And total is going to be equal to total. And here's the math, right? Not that hard. The math is basically saying, take the distributed student amount number. So if there's 100 students and 20% of them are freshmen, take 20 students, multiply that by the table brunch prices. So whatever, the array brunch prices, and then multiply that by 0.5, right? And that would give us half. So if there is 20 freshmen, it costs them $12, that'd be $240 divided by 2. So that gives us $120. You can see where this math, and now all that math, it's important, but it's really, I think is interesting is that we are actually going through 2 arrays at the same time because we lined up those arrays. Let me bring up my screen here. Because we lined up these arrays, I can now go through both arrays in one for loop. Now, if that doesn't make sense to you, stop the video and watch it and really kind of break down. If you pre-plan your arrays and your data structures, it becomes extremely efficient. And then finally, we now have a total. Now we can do our branches or our if statement. Let me scroll this up a little bit. So we came up with a total. That's good. And now we're going to compare that total with the cost of the trip. And we're going to say if total is greater than or equal to the cost of the trip. At the brunch, did they make the same or more money at the brunch than the cost of the trip? And if they did, they're done with fundraising. That's what no says. If they didn't, if the fundraising was less than the cost of the trip, they need to go out and do some more fundraising. So hopefully I typed everything correctly. Let's run this. All right. Sorry for the big jump there. There was a bunch of typos and I do apologize for that. So I copied and pasted the working and moved it over here. I did put some comments in there. Don't worry about the gray lines or anything like that. So now let's run this program and give it a chance to compile. And now let's put some data in there. We have 4,000 students and the distribution is 0.5, 0.2, 0.1, 0.2, and then the total number of students is 400. So 4,000 is the cost of the trip. There's the distribution of students going to the brunch, and there's the total number of students. If we run this, it comes back with yes. If you remember, basically, this is how much they collected and this is the cost of the trip. So they have some more fundraising to do. All right. Now, in the second video, we're going to expand upon this. Now, we're going to stop here on this video because the second video will work through all the logic associated with this particular question or this particular problem. But I want to stop here at this video. It's gone pretty long, because this is the heart of what we're doing. We're creating a list within a program. We're creating a list from some kind of input. We did the split. Then we're creating another list based upon all that other information. And if we've done it right, it lines things up really nice. We can iterate through the entire list and things like that. So let's stop here on this video. And if you want to see how the rest of this logic works out, I've done pretty much 90% of the code, right? I've done a great deal of code because the first thing is just trying to get the money, find out the money and things like that. So hope you watch the second video, but this is a good example of lists. That being said, let's go learn something.